So now let's explore what happens when partial pressure acts on small particles. Let's consider how vapor pressure can affect a particle size. Let's consider this droplet of water. What you don't see is pressure acting on the droplet of water from all sides. If we were to split the droplet in half, we can fully appreciate how two forces are acting on the droplet of water. First, the surface tension, which is given by gamma, which is holding the water droplet together, that is overcoming the vapor pressure that is acting on the water droplet. So the surface tension and the vapor pressure have come to some kind of equilibrium for the water droplet to attain a certain size, and the surface tension is able to withstand the pressure from breaking it apart. So what that means is that at equilibrium, surface tension is equal to total vapor pressure. And hence, we can rewrite this equivalent expression as this equation. Substituting this into the previous equation for vapor pressure P, we will end up with this expression, which can be simplified to this expression. Now, this is a very important equation because it demonstrates the inverse relationship between partial pressure and the radius of particle. So what this means is that small particles or small droplets will have more pressure acting on it. And this really explains the phenomenon of smaller droplets combining with each other to form a larger droplet until it reaches an equilibrium. This is a very important concept in materials engineering, as you can use it to manipulate the strengths and hardnesses of many different kinds of materials. So let's look at this concept in the context of, say, hardening a material. If we were to, say, look at a cross-section of a metal block, you will notice that it's full of grain boundaries. And these grain boundaries are tightly compact into a space. They may be large and they may be small. It is a well-known phenomenon that heating, say, a piece of metal would decrease the particle's size by reducing its vapor pressure. And hence, heating the material over a longer period of time causes the smaller particles to coalesce and form larger particles that make it harder. And this explains the phenomenon of why sword makers tend to heat up their swords, or knife makers heat up their knives in order to make them less brittle and stronger. Thank you, and I'll see you in the next lecture.